In this lesson, we'll learn how to find the area of 4 different polygons. You need to copy these examples down on lined paper, draw the shape the best that you can, write the equation, and then solve the equation along with me. The first polygon we'll look at is a parallelogram. A parallelogram is a slanted rectangle. Opposite sides are parallel to one another, and opposite sides have the same length. Now, one thing that is important about a parallelogram is that the base and the height form a right angle. The base and the height form a right angle, as shown here by this little box that says it's a 90-degree angle. And so if I want to find the area of this parallelogram, this is the formula, base times height. Base, which here is 5, I'll label this B, and the height, which is 3, I'll label that H. Okay, so write this down with me. Area equals the base, which is 5, times the height of 3. And 5 times 3 is 15. The last thing that I need to do is label my units. Since I have centimeters times centimeters, that means I have centimeters squared. Area is in square units. One other note about a parallelogram is that a rectangle would fall into the category of a parallelogram because a rectangle is a special parallelogram since all the angles of a rectangle are 90-degree angles. They are all right angles. The next polygon we'll look at is a trapezoid. A trapezoid, as you can see here, is a quadrilateral, so it has 4 sides, but it only has one pair of parallel sides. Right? A parallelogram has 2 pair of parallel sides. A trapezoid only has 1 pair of parallel sides. It has 2 bases, and those bases are not equal to one another. This base you can see is 6, this base you can see is 4. So it has 2 unequal bases, and the height of a trapezoid is perpendicular to both bases, which means that it forms a right angle, as you can see here. That's a right angle. Now to find the area for a trapezoid, we use this formula. Area equals 1/2 times the height times the sum of the bases, b sub 1 plus b sub 2. You will also see the formula written like this. Area equals the height times the sum of the bases divided by 2. The reason is because multiplying by 1/2 and dividing by 2 is the same thing. Okay, so it does not matter which base you call b sub 1 and which base you call b sub 2 because when you add them together you will get the same sum. So to find the area of this trapezoid here, let's first label the parts. Let's call this b sub 1, that's one of the bases, and this right here b sub 2. So label those parts. Those are the 2 bases. Now I'm going to label the height. The height I see is 4 feet. That's the height. I'll put a little h there. Now I'm just going to plug in my numbers to the formula. Okay, so A, the area, is equal to 1/2 times the height, which is 4. So I'll put 1/2 times 4 times the sum of the bases. So 4 plus 6. I'll add the bases together. Alright, so plug in these numbers to the equation. Now what is 1/2 of 4? Well, 1/2 of 4 is 2. And what is the sum of 4 and 6? Well, the sum of 4 and 6 is 10. So the area is equal to 2 times 10, which is 20. Now the last step is to label the units, which I'm in feet here, so my units will be square feet, feet squared. The third polygon we'll look at is a rhombus. A rhombus sort of looks like a kite. And it is a special type of parallelogram since all 4 sides of the rhombus have the same length. The opposite sides of a rhombus are parallel and they have the same length. To find the area of a rhombus, I take 1/2 times the first diagonal times the second diagonal. Or you could see the formula written like this because again, multiplying by 1/2 and dividing by 2 are the same thing. So you could have area equals diagonal 1 times diagonal 2 divided by 2. Alright, so here in this rhombus I have 2 diagonals, as you can see by the dashed lines that go from one vertex to the other. My 2 diagonals are 4 and 6. Again, it does not matter which one I call diagonal 1 and which one I call diagonal 2 because when you multiply them together you will get the same product. So let's plug this in here. I have area equals, I'm just using this equation, 1/2 times diagonal 1, which is 6, times diagonal 2, which is 4. Okay, so here I have 1/2 of 6. Well, what's 1/2 of 6? That's 3. I still have to multiply by 4. 3 times 4 is 12, and the last step is to label my units, which is square inches. Square inches. The last polygon we'll look at is a triangle. Okay, now to find the area of a triangle, I take 1/2 times the base times the height. Or again, because multiplying by 1/2 and dividing by 2 are the same thing, I can take base times height divided by 2. Now triangles will look different ways, but one way the triangles can look is if it's a right triangle, which means that that triangle has a right angle. This 5 would be the base, that's the base, this is the height, and so if I do base times height, let's plug this in, area equals 1/2 times the base of 5 times the height of 4. Okay, so I have 1/2 times 5 times 4. Well, 5 times 4 is 20, and what's 1/2 of 20? 1/2 of 20 is 10. So it's 10 centimeters squared because this is area. You can also have a triangle that looks like this, where you have a dashed line from one vertex down to the base that forms a right angle. And so this 6 would be the base, this 7 would be the height. And so if I plug this in, area equals 1/2 times the base of 6 times the height of 7. Well, 7 times 6 is 42. What's half of 42? Well, half of 42 is 21. So 21 centimeters squared would be my area of this triangle. The last triangle we'll look at, you can also see a triangle that looks like this, where the triangle is here, but we have these little dashed lines that tell us what the height is. So my base here is 6, from here to here is 6 centimeters, but how tall is it? Well, it's 3 centimeters tall, so that's the height. These dashed lines right here are telling me how far it is from here to here. So area equals 1/2 times the base of 6 times the height of 3. 6 times 3 is 18, and half of 18 is 9. The last step is to label my units, centimeters squared.